Hey guys, today we're going to be talking about solving square root equations, which is 10.2, root equations. So starting off with our learning goal, our learning goal is I will solve square root equations including those with square roots on both sides, and I will identify extraneous solutions. So extraneous is going to be one of our vocab words today. We'll get to what that means in just a minute. So as far as square root equations goes, here's the big idea of what we're talking about. We know if two things are equal, so if A equals B, then A squared is going to equal B squared. So if two expressions are equal, then their squares are equal also, and that should make sense. So we're going to use this piece of information to help us solve our square root equations. So our first example, if we know that the square root of x plus 1 equals 4, we want to solve for x. So the big thing that we want to notice here, the 1 is not under that square root sign. So you want to be super careful that you're making it very clear what is under the square root and what is not. So in this case, it's just the square root of x plus 1 equals 4. So to solve this, I want to get the square root by itself. So the first thing I will do is I will subtract 1 from each side, and I get that the square root of x equals 3. And then from here, I'm going to use this rule up here that if two things are equal, then their squares are also equal, and I'm going to square each side. When you square a square root, it undoes it. It's the inverse operation, squaring and square roots. So we're left with just x here. When I square 3, I get 9. So I get x equals 9. I am going to take that and I'm going to stick it in there just to make sure that it works. So I get the square root of 9 plus 1 equals 4, hopefully. The square root of 9 is 3. Plus 1, does that equal 4? Let's see, 4 equals 4. Yes, it does, so our solution is correct there. Okay, let's do another quick example. If I have, actually let's call this 1b. If I have 7 minus the square root of x equals negative 5. Let's see what I'm going to do here. So I'm going to start off by subtracting 7 from each side. So the negative square root of x equals negative 12, which means if it's the opposite of the square root of x equals negative 12, if I divide each side by negative 1, I get the positive square root of x equals positive 12. And again, I can just do my rule from before, which was square each side. So the square root of x squared is x. 12 squared is 144. So let's check that. 7 minus the square root of 144, does that equal negative 5? That would be 7 minus 12. 7 minus 12 is negative 5, and those are equal. So negative 5 is my answer there. So I want you to try one on your own for me. If we have, how about the square root of x minus 7 equals 3. So go ahead, pause, try that. Make sure you check your answer and turn it back on. Okay, I'm going to add 7 to each side because the whole goal is to get that square root by itself first. So when I add 7 to each side, I get the square root of x equals 10. Now to undo the square root, I square x equals 100. So if we put in 100, the square root of 100 minus 7, does that equal 3? That's 10 minus 7, which happens to be 3. So hopefully you got 100 for your answer here. Okay, so now obviously we can get a little bit more complicated. So for example 2, let's just look at a more complicated version of this. 3 times the square root of x plus 1 minus 6 equals 9. So in this case, you'll see that x plus 1 is what's under that square root sign. So I really want to follow the same method. I want this whole thing by itself before I do any squaring. So I want only a square root on one side before I square. So to solve this one, I am going to start off by getting rid of this negative 6, or subtracting 6 that's hanging off the end. I'm going to add 6 to each side to take care of that. So I'm left with 3 times the square root of x plus 1. That's going to equal 15. Now, this is 3 times my square root, so I want to divide each side by 3. When I do that, I'm left with just the square root of x plus 1 on this side, and I'm left with 5 over here. So now, since I only have a square root, I can square each side. So the square of a square root is just what's under the root. So I'm left with just x plus 1 over here. And on this side I have 25. I'm going to subtract 1 from each side, and I get x equals 24. So again, I can take this 24, put it in for that x. So let's see, 3 times the square root of 24 plus 1 minus 6, does that equal 9? 3 times the square root of 25 minus 6, so that's going to be 3 times 5 minus 6, does it equal 9? 15 minus 6, 9 equals 9. Hooray, we have the right answer. And let's do another example. So in this situation, we're actually going to have a square root that we're starting off with on each side. So square root of 2x plus 2, all under that root, equals the square root of 3x minus 7. So here I have just a square root, here I have just a square root. So I'm going to square each side to start off with. When I square a square root, I'm just left with what's underneath. This will be 3x minus 7. And now I can solve this just like every other problem I've done with a variable on both sides. I am going to add 7 to each side. So 2x plus 9 equals 3x. I'm going to subtract 2x from each side. And I'm left with 9. 3x minus 2x is just x. X equals 9. I can substitute that back into my original equation. Square root of 2 times 9 plus 2 equals square root of 3 times 9 minus 7. This would be 18 plus 2, square root of all that. This is going to be 27 minus 7. Does the square root of 20 equal the square root of 20? Yes, it does. I don't need to go any further and actually find the square root of 20 because, well, square root of 20 equals square root of 20. Easy enough. So now let's have you try just one more on your own for now. How about you try the square root of x equals the square root of 5x minus 1. What I'm going to do here is again square each side. X equals 5x minus 1. Let's subtract 5x from each side. I'll get negative 4x equals negative 1. Divide each side by negative 4. X equals 1/4. So now I can check it. The square root of 1/4 equals the square root of 5 times 1/4 minus 1. That's 5/4 minus 4/4. 1 is just 4/4. So the square root of 1/4 equals the square root of 1/4. Hooray! So let's try another one. Okay, so we're going to try another one. It looks just a little bit different, but again, we're using that same method where x equals square root of x plus 20. So I'm going to do the same thing here. I have a square root by itself, so I'm going to start off by squaring each side. So I have x squared equals x plus 20. Now what I have here really should look like a quadratic to you. So let's get this set up where I subtract the x and the 20 from each side. So x squared minus x minus 20 equals 0. From here I can use whatever method I want to factor, or to solve this. I'm going to factor it because that tends to be the easiest. So I need two numbers that multiply to give me negative 20. So one has to be positive, one has to be negative. Add to give me negative 1. So the bigger number has to be negative. 20 is 1 and 20. That won't add right. 2 and 10 won't add right. 4 and 5 do though. So if I have a positive 4 and a negative 5, when I add them, the negative number makes negative 1. Or when I find the difference, I guess. So my answer then would be x equals 5 or x equals negative 4. So what I want to do here is I want to then check my answers. So go back up to this x equals square root of x plus 20. So let's do 5 equals square root of 5 plus 20. Does 5 equal the square root of 25? Yes, it does. So there's my answer. Let's also check my negative 4. So negative 4 equals the square root of negative 4 plus 20. So when I do that, I see that I have a little bit of a problem. Can negative 2 equal a square root? Does negative 2 equal the square root, does negative 4 equal the square root of 16? Well, I can't take a square root and get a negative number. So therefore, this is not going to work. So this right here is what we call an extraneous solution. So because we're squaring each side, we are actually introducing the possibility of having an answer that doesn't actually work. So in this case, we have what's called an extraneous solution, and negative 4 is our extraneous solution. So if we end up with something that when we do it out, we get an answer that doesn't work, we know square roots can only give us a positive answer, we call that extra one an extraneous solution. So you actually need to go through and check all of your answers to make sure we're not getting something that's extraneous. Our final problem here is an example of a physics problem. So the period p in seconds of a pendulum is given by the function p equals 2 pi times the square root of L over 32, where L is the pendulum length in feet. What is the length of a pendulum that has a period of 3 seconds? So in this situation, we have a pendulum, so it's like something on a string. And as your book tells you in the study tip, the period is the amount of time it takes for a pendulum to swing back and forth. So if you're swinging a pendulum, the period is back and forth. So it takes 3 seconds for it to go up and back. So what we want to know is how long is this string if we want that period to be 3 seconds long. So we're going to put in 3 for P into this formula that they gave us. So 3 equals 2 pi times the square root of L over 32, and we're trying to solve for that L. So what I'm going to do first is I'm going to divide each side by 2 pi, and divide u by 2 pi. So I have 3 over 2 pi on the left side, and that equals the square root of L over 32. Now to undo the square root, I'm going to square each side. 3 squared is 9. I'm going to go back up here to finish this. 3 squared is 9. 2 pi squared is 2 squared, which is 4, times pi squared. And that's going to equal L over 32. Because I've undone my square root, I'm not going to deal with that pi squared yet. I'm going to try and get it so I just have numbers. So L over 32 means I have to multiply each side by 32. And a lot of you probably want to get your calculator out right now, but I'm actually going to go one step further. I know that 4 goes into 4 once, and 4 goes into 32 8 times. So I have 8 times 9 over pi squared, and that's going to equal L. So now is when I would get my calculator out to do 72 over pi squared. So let me grab my calculator. Oh, come on, it doesn't want to behave. Oh, come on. There we go. Okay. So I'm going to do 72 divided by, and then in parentheses, where's my pi button? Oh, do I not have pi? Oh, there it is. Pi squared, close parentheses, and I get 7.3. So that tells me that my pendulum needs to be about 7.3 feet long to have a period of length 3 seconds.